In this video, we'll explore what Docker is, why it was created, and the problems it aims to solve. You'll learn how Docker simplifies software development and deployment, making it essential for modern IT projects. Plus, we'll see why Docker has become so widely popular. So, we will discuss what a container is and what problems it solves. We will also take a look at a container repository, which is essentially a storage for containers. We'll see how containers simplify and improve development by isolating applications and dependencies for better efficiency. We'll also see how containers help solve common challenges in the application deployment process, making it more efficient. So, we'll talk about what a container is. A container is a portable way to package applications with everything they need to run, such as dependencies, configurations, and libraries, ensuring that the app works seamlessly across different environments. This package is portable, just like any other item, allowing it to be easily shared and moved between the development and operations teams, simplifying the transition from development to production. The portability of containers and package everything into an isolated environment makes development and deployment more efficient. This eliminates the need for complex setup. In the next slides, we'll explore how this process works in more detail. As I mentioned, containers are portable, which means they require a storage system to allow easy sharing and movement between different environments. Containers reside in a container repository, which acts as a specialized storage system for managing them. Many companies set up their own private repositories to securely host and store their containers, ensuring control over their deployment and distribution. This is how it looks, where you can push all your containers. Docker also has a public repository, where you can browse and find application containers. This helps developers quickly access popular containers, ensuring compatibility. Now, let's see how containers have improved the development process with specific examples. How did we develop applications before the use of containers? Typically, when working on an application with a team, you need to install most services directly on your operating system. This can lead to conflicts and version mismatches, making the process more complex and time-consuming. For example, if you are developing a JavaScript application and require messaging services, each developer in the team will need to install the binary files of those services on their individual systems. They will need to configure and run these services in their local development environment. The installation process will vary depending on the operating system they are using, and each developer will have to manually set up everything, which can lead to inconsistencies and errors in the environment. Installing services this way comes with another problem. It involves multiple installation steps, which can lead to inconsistencies across different machines and environments. You have to execute multiple commands, and the chances of something going wrong or errors occurring are quite high, as the number of steps and approaches required to install each service is significant. Setting up a new environment can be quite tedious, especially if your application is complex. The process that need to be handled correctly to avoid errors. For example, if your application consists of 10 services, you'd have to repeat the installation and configuration steps for each service on every developer's system. Now, let's explore how containers solve these issues. With containers, you don't need to install services directly on your operating system. The container provides its own isolated environment, including dependencies and configurations, based on a specific image. This ensures consistency across different systems. As we saw earlier, everything is packaged in an isolated environment. For example, a specific version of PostgreSQL, along with its configuration and startup scripts, is packed into a container. As a developer, you don't need to manually download and install binaries on your machine. Instead, you can simply search and download it directly to your local machine. This makes setting up the necessary services quicker and much easier. Downloading is done with a single Docker command, which fetches the container and starts it simultaneously. The same command works consistently across all operating systems, making the process simple and efficient. For example, if your JavaScript application depends on 10 services, you only need to run 10 Docker commands for each container, and everything will be up and running. This significantly simplifies the process of setting up your local development environment and makes it much more efficient than traditional methods. Plus, as we've discussed earlier, you can easily run different versions of the same application in your local development environment without any conflicts. Now, let's look at how containers improve the deployment process. Before containers, the traditional deployment process looked something like this. The development team would create the necessary artifacts and provide instructions on how to install and configure them on the server. These instructions would also include setting up databases or other services required by the application. The challenge was that every server required its own set of manual configurations, leading to potential errors or missed steps. This traditional deployment process was time-consuming and prone to inconsistencies between different environments. Additionally, using containers simplifies the deployment process even further. Since all the necessary configurations, dependencies, and the application itself are bundled into the container, the operations team only needs to execute one command to run the container on the server, regardless of the operating system. This eliminates the need for complex setup instructions or managing different service versions, which can often lead to issues. Moreover, containers allow for a consistent environment across different stages of development, testing, and production. This consistency drastically reduces "it works on my machine" problems that often occur when code behaves differently in various environments. It also makes scaling the application easier, as containers can be quickly replicated and deployed across multiple servers. With just a few commands, a development team can replicate their entire environment on a new machine, and the operations team can easily manage updates or roll back to previous versions, making the process far more agile and efficient. Furthermore, containers ensure that the application behaves the same way across various environments, whether it's development, staging, or production. This consistency eliminates the common "works on my machine" issue, where an application might function differently on developers' local machines compared to the production environment. With containers, you don't need to worry about system-level dependencies or version mismatches, as everything required by the application is bundled inside the container. The operations team simply needs to pull the image, and the application can be run seamlessly across any server. This approach also supports faster scaling, as containers can be replicated quickly and run in parallel across multiple servers to handle increased load. In short, the process is more efficient, less error-prone, and promotes smoother collaboration between the development and operations teams, enabling faster releases and better overall management of the application lifecycle. So friends, if you liked this video, please don't forget to like and subscribe. And let us know in the comments what else you'd like to learn about Docker. See you in the next video.